Hey everyone, this is Mukesh from CodeWithMukesh.com, and in this video we'll be learning about Amazon DynamoDB and how we can integrate with your .NET applications. We'll go through the basics of DynamoDB like creating a first table with the partitions and shortkeys, getting familiar with the management dashboard, which will be helpful if you're a complete beginner to this service. We'll also build a simple ASP.NET Core Web API that performs create, read, update and delete operations over a specific entity in DynamoDB. This video is sponsored by AWS and is part of my ongoing .NET on AWS series, for which I have already posted a couple of videos and articles both on my YouTube channel and on my blog. I will leave the links below in the description in case you want to follow along with this series. Let's get started. Before getting into the details, let's understand the core concepts. DynamoDB is a managed serverless NoSQL database service from AWS. NoSQL databases are generally used for high traffic applications. DynamoDB offers highly scalable and available database instances with low latency for applications that need fast and reliable access to a huge amount of data. And how would you authorize yourself to use this AWS service? It's pretty easy. It's going to be the same as you would do for any other AWS service. We'll be using IAM policy for this within our .NET application, which we will see in a later section of this video. Now, DynamoDB is a key value based database, which is a pretty popular variation of NoSQL databases. Apart from this, on the pricing front, AWS offers up to 25 GB of free storage, which is more than enough for your small projects and for you to play around with the school service. You can also get the free tier account from here if you don't already have it. The core concepts includes tables, items and attributes. Now, tables are collections of data, records or items, and items are collection of attributes. Here, each of the columns of a particular table are also known as an attribute. Now, to identify a particular record, we have primary keys, right? So here, the primary keys are split into partition keys, which is mandatory, and the sort key, which is optional. In this example, the product table have attributes like ID, barcode, and name. The partition key is the ID, and the sort key is the barcode, and every other column is an attribute. Now, let's log into AWS Management Console to get familiar with the DynamoDB dashboard and create our first DynamoDB table. Here, search for DynamoDB and open it up and click on tables. So as you see, I currently do not have any tables in this particular account. Click on create table. Note that here we are trying to create a table and not a database. As I already mentioned, this is a completely managed serverless service and the underlying infrastructure concerns are handled by AWS for us. So I'll create a simple products table with a couple of columns like ID, barcode, name, description and so on. I'll name this table as products. Next, we need to define the primary keys for the table. So understand that the primary keys are used to identify a record from the table and has to be unique. Here, the primary keys are split into two parts, that is a partition key and the sort key. The partition key is mandatory and the sort key is optional. I'll add ID as a partition key and barcode as the sort key. Let's keep both of these attributes as string. So note that you cannot change this later on. You cannot add or modify a sort key after the table is created. Keep this in mind before deciding the attributes of your new table. In this case, we'll assume that we'll have multiple records with ID as 1 but with a different barcode. But in case, if every record of your product table will have only a single and unique entry into the table, you do not need a sort key. That's it. Let's leave everything else to default and create this table. We haven't added other columns like description, price and names, right? We'll be doing that in the part of data entry. It will take a couple of seconds before your table is created. Once created, let's open up our new table. So you can verify the primary keys from here. Click on Explore Table Items. As you see, there are no records in this particular table. Let's add a new record by clicking on Create Item. I'll set the ID as 1 and barcode as something like 123. So you can also add additional attributes, which we'll be doing. So let me add a new string, which will be the name of the product, and I'll give it a name of test. And I'll add one more column that will be description. I'll add some random values here, and let's add one more integer column that will denote the price of this particular product. And let me give it a decimal value. Once you have added all the attributes and the values, you can just click on Create Item. So you can see that the new item is created for you. From here you can use the scan and query operations. For example, you can select query and search for a product with ID S2, which we know that doesn't exist, and click on run. As expected, you can see that there is no data returned. Similarly, you can also use these filters to search against a particular attribute like price or name. So these are the basic concepts of Amazon DynamoDB table. Let's move to the next section where we'll build an ASP.NET Core Web API that performs CRUD operations over this product table that we have created. Before proceeding, ensure that you have Visual Studio installed on your machine along with the latest .NET SDK. You should also have at least a free tier account of AWS and make sure that your system is configured to access AWS resources. So I generally use the AWS CLI profiles to configure the AWS credentials in my system so that my .NET applications can authenticate into AWS. If you need to do the same, refer to this video where I talk about various ways of credential generation and management. I have linked this video in the description as well.
I also wanted to highlight a best practice for using IAM credentials. Since IAM allows you to choose permissions for a particular user or group in a very granular way, we will also have to be very careful with this. I mean, when you create a new user or a group, you should specify only the service you need to provide access to and not give unnecessary permissions. If other permissions are given randomly, it might even compromise your entire AWS account. So for example, in our case, the ASP.NET Core Web API that we are building needs only DynamoDB permissions. So let's go to the AWS Management Console, IAM and Policies, and let's create a new policy. So here I'll select DynamoDB and give the required DynamoDB related permissions like list, read, write and tagging. For now, I'm going to give all the actions related to DynamoDB. Now, if you want an even finer definition of permissions, you can give access to only a specific DB table as well. So once the policies are created, you can attach this policy to a specific user or a group. For now, I'm going to give the permissions to all the DynamoDB tables. So once this policy is modified and created, I'll just give it a name and probably attach it to a user or a group that I'll be generating. So from there, you can generate credentials for the user and configure the secret keys in AWS CLI profile. So as I said earlier, you can follow this particular video for setting up everything. Once everything is done, let's build our ASP.NET Core Web API. You'll have to open up Visual Studio and create a new Web API project. I'm using the .NET 7 SDK for this implementation. So I'll just reiterate on what we are going to build. So it'll be a simple .NET 7 Web API which will access the DynamoDB products table that we created earlier and perform CRUD operations over it. As in creating a new product, getting the product details by barcode and ID, update and delete. I have already written the code ahead of time. Let's go through it. Note that you can find this entire project on my GitHub, the link to which is mentioned in the description section of this video. Firstly, as soon as you create your Web API project, you'll have to include these packages which are related to AWS for accessing DynamoDB. So these are the core, DynamoDB v2 and the extensions package. So once that is done, head over to program.cs to register the AWS services. So I have added these lines to specify the AWS CLI profile that we are going to use and to register the DynamoDB service into the application DI container. And coming to the app settings.json, you'll also have to add this AWS section to your app settings where we specify the CLI profile and the AWS region. Next, we'll create a product model which is going to denote the table that we have created earlier on our DynamoDB via AWS Management Console. So if you don't remember, it is a products table. So I added the product class along with these 5 properties that we also added there, that is ID, barcode, name, description and price. Note that we have also written attributes to each of these property and to the class as well. Since the class name is different from the name of the actual table, we will have to explicitly mention it as DynamoDB table attribute products. Then, for the primary keys, which are a collection of hash and the range keys, I have specifically set the hash key as the ID and the range key as the barcode. The other properties will have the DynamoDB attribute with the actual attribute name as in the table. Now, let's go to the product controller that has the CRUD logic. Ideally, we should be putting all this code at some product services or something to keep the controller clean. But for this demonstration, let's keep it simple. Let me know if you're interested to have a video where we build a .NET API from scratch using clean or vertical slice architecture so that we can cover some clean code concepts. Let me know in the comment section below. So I have the get by ID and barcode, get all, create a new product, delete a product using ID and barcode, and update a new product. We'll go line by line. Firstly, I injected the DynamoDB context into the controller's constructor. This context will be used in all the API endpoints. So first, in the get endpoint, we are accepting ID and barcode as string. We then try to load the particular product that has a match with the incoming ID and barcode. If found, we print out the product, else it will be a 404 not found. In the getAll method, we use the scan method to load all the records from the product table and return a list of products. And in the create method, we accept a product request. We will first check if a product already exists with the specific ID and barcode. The product will be created only if it doesn't exist already. Similarly, we have the delete and update endpoints. That's all for the development part. Let's run the API and use the Swagger to test the endpoints. Here are the endpoints that we had added earlier. We know that our table has only one entry with ID 1 and barcode 123. Let's use the get endpoint to check this. So let me open up this, click on try it out, set the ID as 1 and barcode as 123 and hit on execute. You can see the data returned from our table. Now let's try to add a new product. So for this, let me open up the post endpoint, click on try it out, maybe set the ID as 2 and keep the barcode same as 123 and maybe set the name something like test and set the price to 101 maybe and hit on execute. You can see that we have a 200 success status code from the API. So this means that ideally the product has to be added into the DDB table. So let's head over to DynamoDB table and verify that this product has been added. Let me switch to the tables. So here are the tables. Let me open up products, explore table items and hit on refresh. So as you can see, this is our new product, that is 2, 123 test and 101 is the price. So going back to Swagger, let's try to delete the older product maybe. So let me use the delete endpoint, hit on try it out, 1, 123 and execute. So here if you see we have a 204 status and let's head over back to DynamoDB and refresh this table. So again, the ID with the product with the ID 1 is gone. So similarly, you can also get a list of the products that are already available. So for example, maybe let us add one more product, maybe with an ID of 3 and hit on execute. So the product is created. And now let's use the get endpoints that actually returns a list of product and not a specific product. So hit on try it out and click on execute. So if you can see, here is a list of products that is coming from the database. And if you want to verify, let me just load it again. You can see that these are the two records that have been added to the table. Similarly, you can also try out the update endpoint, which is actually going to update a particular record in our DDB table. That's all for this video. In the next video, we'll learn about Amazon API Gateway in AWS, where we'll build and expose API endpoints that can send in requests to these Lambda functions. Imagine a CRUD functionality where we'll have a standard read and write operations. In that case, there will be a separate Lambda function for each of the CRUD operations that we are going to do via DynamoDB, which will be ultimately tied together with the help of API gateways. You'll find the source code of this demonstration in this particular repository, the link to which you can find in the description. The source code of all the upcoming tutorials on my .NET on AWS series playlist will be available on this repository. Apart from that, to read the text version of this video, you can refer to this blog post. I hope that you have enjoyed this video and do not forget to like this video and subscribe to my channel for more upcoming videos. Thanks, and I'll see you in the next video.